Today we are going to learn about mastering Python's Lambda functions. We will explore how to efficiently use Lambda functions to write concise and readable code, enhancing your coding skills for real-world applications. Welcome to this educational video on mastering Python's Lambda functions. Lambda functions in Python are essential for creating small, anonymous functions that can simplify coding tasks. These functions allow you to write concise and readable code, making them a powerful tool in a Python programmer's toolkit. In this video, we'll introduce you to Lambda functions, explore their syntax and structure, and delve into various use cases. You'll learn the differences between Lambda and regular functions, and how to implement Lambda in sorting operations. We'll also cover using Lambda with map, filter, and reduce, and discuss performance considerations and best practices. By the end of this video, you'll have gained the ability to implement Lambda functions in real-world scenarios, enhancing your code's efficiency and clarity.
Lambda functions in Python are defined using the keyword lambda. The syntax is quite straightforward. You start with the keyword lambda, followed by a list of arguments, a colon, and then the expression. The result of the expression is returned automatically, so there's no need for explicit return statements.
For instance, if you want to create a simple function to add two numbers, you can use a lambda function like this, lambda x, y, x plus y.
This makes lambda functions ideal for short, throwaway functions that are not complex enough to warrant a full function definition. They can be executed inline wherever they are needed, which can make your code cleaner and more concise. However, it's crucial to remember that lambda functions are best suited for situations where you need a simple function for a specific, short-term task. If your function logic is complex or requires multiple statements, a regular function is the better choice.
Lambda functions are incredibly versatile and can be used in various contexts in Python programming. One of their primary use cases is in data processing pipelines, where they can be applied to elements of lists or other collections to perform operations like transformation or filtering. This is particularly useful when combined with functions like map, filter, and reduce, which we'll discuss later. Lambda functions are also ideal for short-lived operations that don't require a separate named function, such as a simple calculation or string manipulation. In event-driven programming, Lambda functions are often used for callbacks, where they can provide a quick, inline function to handle an event. Another common use is in GUI development, where Lambda functions are used to define button click handlers or other user interactions without cluttering the code with multiple small function definitions. By using Lambda functions, you can write cleaner, more concise code that is easier to read and maintain, especially in scenarios where brevity and simplicity are valued. While Lambda functions and regular functions in Python serve similar purposes, they are quite different in their structure and use cases. Lambda functions are defined with a single expression and are anonymous, meaning they do not have a name. This makes them suitable for short, simple operations that are used temporarily. On the other hand, regular functions can contain multiple expressions and statements, and they are defined with a name, allowing them to be reused throughout your code. Regular functions are better suited for complex logic that requires multiple steps or needs to be called multiple times. Choosing between a Lambda function and a regular function comes down to the complexity of the task at hand. If you need a quick, one-off function for a specific task, a Lambda function might be the way to go. However, if your function needs to perform multiple operations or is part of a larger workflow, a regular function is more appropriate.
Lambda functions are incredibly useful when it comes to sorting operations in Python. You can use a lambda function as the key function in a sort operation, allowing you to define custom sorting logic succinctly. For example, suppose you have a list of tuples, and you want to sort them by the second element. You can achieve this using the sorted function and a lambda function like this, sorted list underscore of underscore tuples, key equals lambda x, x1. This approach simplifies the sorting logic, making your code cleaner and more readable. Moreover, lambda functions can help you sort by multiple criteria, adding flexibility to your sorting operations. For instance, you can sort a list of dictionaries by one key first and then another by using a tuple in the lambda function, sorted list underscore of underscore dix, key equals lambda x, x key 1, x key 2. This capability is particularly useful in data analysis tasks, where you often need to sort data based on various attributes. By using lambda functions in sorting operations, you can streamline your code and enhance its readability and efficiency. The map function in Python is a powerful tool for applying a function to all items in an iterable, such as a list or tuple. When combined with lambda functions, it becomes even more efficient and concise. A lambda function allows you to define the transformation you want to apply to each item inline, without the need for a separate function definition. For example, if you have a list of numbers and you want to square each one, you can use the map function with a lambda like this, map lambda x, x2, list underscore of underscore numbers. This approach simplifies the transformation process and can replace loops when you need to apply a simple operation to each element in a collection. Using lambda functions with map not only improves the conciseness of your code but also makes it more readable by clearly expressing the transformation logic in a single line. This is particularly beneficial in scenarios where you need to perform multiple transformations on data for analysis or processing. The filter function in Python is used to select items from an iterable based on a condition. When used with Lambda functions, it provides a concise way to define the filtering condition inline. This makes it an excellent tool for streamlining data filtering tasks. For instance, if you want to filter out even numbers from a list, you can use filter with a Lambda function like this. Filter lambda x%2 equals 0, list _of numbers. This approach replaces traditional loop-based filtering, where you would need to explicitly iterate over each item and apply the condition. By using Lambda functions with filter, you can enhance the readability and conciseness of your code. It allows you to express the filtering logic clearly in a single line, making it easier to understand and maintain. This is especially useful in data processing tasks where you need to apply multiple filters to extract specific subsets of data.
The reduce function in Python is used to aggregate data in an iterable to a single cumulative value. Part of the functools module, it becomes even more powerful when used with Lambda functions, which allow you to define the aggregation logic in a concise manner. For example, to calculate the product of all elements in a list, you can use reduce with a Lambda function like this: reduce lambda x, y, xy, list _of numbers. This approach simplifies reduction operations by allowing you to express the cumulative calculation logic in a single line. It is particularly useful for tasks that require combining elements, such as summing a list of numbers or concatenating strings. By using Lambda functions with reduce, you can streamline your code and focus on the logic of the operation, without the need for explicit loops or additional function definitions. This enhances the readability and efficiency of your code, especially in scenarios where reduction operations are a key part of data processing or analysis tasks.
When using Lambda functions in Python, it's important to consider their performance implications. While Lambda functions are efficient for small, simple tasks, they do have a slight overhead compared to regular functions. This is because they are executed inline and do not have a predefined name or scope. As a result, Lambda functions are best suited for short-lived operations that do not require complex logic. For more complex tasks, regular functions are generally more efficient and easier to maintain. Regular functions also offer better readability and debugging capabilities, as they can contain multiple statements and expressions. When deciding whether to use a Lambda function or a regular function, consider the readability and maintainability of your code. In many cases, the clarity provided by a regular function outweighs the brevity of a Lambda function. Additionally, profiling your code can help identify performance bottlenecks and determine whether Lambda functions are contributing to any issues. By balancing performance considerations with code clarity, you can make informed decisions about when to use Lambda functions in your Python projects.
To get the most out of Lambda functions in Python, it's essential to follow best practices that ensure your code remains readable, maintainable, and efficient. First and foremost, use Lambda functions for simple, single-use operations where their conciseness and brevity shine. Avoid using Lambda functions for complex logic or tasks that require multiple statements, as this can lead to code that is difficult to read and maintain. In such cases, a regular function is a better choice. Prioritize code readability by ensuring that your Lambda functions are clear and self-explanatory. When combining Lambda functions with map, filter, and reduce, do so wisely, focusing on clarity and the specific task at hand. These combinations can be powerful, but they can also lead to convoluted code if not used carefully. Finally, document the usage of Lambda functions in your code comments, especially when their purpose might not be immediately obvious to other developers or even to your future self. By following these best practices, you can leverage the power of Lambda functions while maintaining high standards of code quality and readability.
In conclusion, mastering Python's Lambda functions can significantly enhance your ability to write efficient and readable code. These functions are ideal for simple, inline operations where their brevity and conciseness are most beneficial. By combining Lambda functions with Python's built-in functions like map, filter, and reduce, you can unlock powerful data processing capabilities. However, it's crucial to balance the simplicity of Lambda functions with the readability and maintainability of your code. Avoid using Lambda functions for complex logic or tasks that require multiple steps. Instead, focus on using them where they can provide the most value. With practice and careful consideration of the best practices discussed in this video, you can master the use of Lambda functions in real-world scenarios, enhancing your coding skills and overall code quality. Thank you for watching, and happy coding!